Hello. I'm back to streaming this Saturday morning, early Saturday morning. And the plan for today is a little bit different. I'm going to take a brief pause in my foray, my exploration, my journey into implementing the X11 protocol. I'm going to pause that, and then I'm going to work on something else. And this is because something came up during the coding session yesterday where I realized I had a significant lack, or I lacked a certain structure or data structure in order to continue forward reasonably. And that is a free list or pool allocator. Basically, well, let's actually just pull it up. So we can pull up this C file. So there is a point where I am, let's see, right. I'm receiving, no, let's go here. Yeah. Right. This function here, xInternAtom. I am basically, I have a temporary allocation or temporary arena here, and I'm using that to build a simple list to populate X11 events. And the problem is that I want to be able to simultaneously or at the same time remove events from that list while also assigning new memory to append to that list. And it's not very easily done with with an arena. Well, it is. Well, I assume it is easily done. It's just I haven't done it yet. because when I removed an event from this list, from this, the memory is still there in the arena. It's still being blocked off because like, I guess I can. Let's all right. So I can use this. So let's say your arena is right here, and it's reserving a block of memory, and the first block is is an event, and then you just assign more and more memory ad infinitum. Okay, and then we go here and we need to consume that event. And then once we consume that, we don't really want that anymore. We don't want this we don't want this block of memory to I guess we don't want this block of memory to waste space, but it is wasting space. And it might even be like this, where it's not being removed from the list in order. So it's not easy to discern whether to delete to free up that memory or not. And so what a pool allocator will do or might do, or free list might do, is to keep a linked list of these empty spots, or the addresses of these empty spots, and then parcel them out once we need to assign memory to a new event, or a new X11 event, I mean to say. And so that's what I want to do. Let me just delete this now. Right. Oops, I forgot to add that. Whatever. So let's copy this to, like, I guess we'll say pool.do. And we'll just create a new C file here, one that we can use to explore this stuff. What else? Oh yeah, I need to add this. And then maybe I should look at the C flags. Really necessary. All right. And then I can just go up here, copy all this. Probably won't need it, but good to have it. So I'll just delete all this, actually. And I want to create a basic hello world program. All right. Then how do I usually go about this? All right. So and then I'll just copy these lines. All right. So I have a hello world, and I do need to define a sort of structure because a pool allocator works best with a known data structure. We'll define that. We'll just say data. We'll say node. And Well, for now, we're just gonna put some random data. We'll just put some data in here, and yeah. I guess what I'll do is first I'll create a linked list of this data. So something like this. And then I can create something like this. And then all right. And then let's drain this memory a little bit. And then copy these functions. And just, it's really just slist. Okay. Similar. What's going on here? Incompatible pointer types assigned to. Node. Incompatible pointer types assigning to struct node star from struct x receive node. Ah. There we go. I'm not really doing anything with this though, so I need to do something. There's something I can easily. Oh, I guess I could. Yeah. Okay. Yeah, sure. And then I do want to print this, so Ah. Okay, cool. So we have a node list, and we're printing that list. And now we want to remove. We have to remove. First, we need to be able to remove items from the list. And let's see. Let's go ahead and look at. User include this q.h. So we can remove stuff. How does OpenBSD go through this? What does Q invalidate? If defined Q macro debug. Oh, so it just so it sets this to null, or I guess if you, I don't know what this does. Weird. If this is defined, so I guess debug mode or kernel mode, and they set a null pointer or a void, like a void pointer, or, and then otherwise they don't do anything, I guess. Okay. Okay, so if head okay, if element is equal to head, then remove the head. Otherwise, I guess you go, you go through each element until, let me see, current, you get the current element equals so you start with the head, and then you check while, so this code is, iterating through each element, the next element on the list, until finally you get the element you're looking for, and then it breaks out of that loop, and then it's basically saying, let's see, cur element dot field SLE next, okay, and then equals the next. The next. Okay. All right. And then remove after is taking the head. So, okay. So let's go ahead and I guess we'll define slist remove head, something like list, and I guess that's it. Likewise, we'll define slist remove, then node type. I think, yeah, okay. And then we'll do the same thing for queues. Oops. Right here, simple queues, yeah. And Go down here. Right, simple Q. Or is it SQ? I guess it's a simple Q. Remove head. If I need it, then I'll define it, but otherwise, I'm not gonna bother. So for slist remove, we'll say expression. And then also so if we want to remove the head, insert head slist next equals slist first. Right. Okay. So what it's doing here is saying the element next is whatever is the current first, and then the head, the list's first, the list's head is equal to the element. So let's just say let's see, list first equals node. Okay. And then the next element oh wait, no, I was looking at the wrong thing. So the first element is equal to okay, is equal to the list first, and then that's whatever the next one is. Yeah, I believe this is correct. So the first element is equal to the first's next element, and that will remove the head. And then all right, and then here we can say if slist first equals node, and else we can, so if the node is the first, then we just remove the head. Okay. And then otherwise we need to iterate. Can we just use for each? For each. Hello, 6412. Sorry, I didn't see you there at first. Still doing C, I see. Yeah, I guess I still am. Let's see. Let's see. I guess I need to declare a type. Um, Type current, and then last time you watched was on IO buffers on my channel. Oh, cool. Yeah, thanks. Welcome back. Let's see. And then we can say slist for each current L. And then then we can say if current next equals node. I'm gonna say, yeah, node, and then we just break out, and then we can say slist current next equals current next. Right. Okay. So that should probably do it. For this, I do want to return back the node. Struct node. Return node. Okay. Then we can say struct node 1. All right. And then let's print that out, and then node slist remove. So we need to pass in the list, the node. So let's move node 2 first, and then we'll pass in the type struct node. Oh, I need to print it again. Oh no. Oh wait, those are just warnings. Cool. That seems to be working. And then we can say slist remove slist node 1 struct node. And then okay. Well, I should probably let's go ahead and this so that there's some indication that I can see visually. All right, so yeah. First, we removed the middle element, and then we removed the first element. So that seems to be working as expected. But if we inspect the memory on the arena, we'll definitely see that these nodes are still allocated to the arena, even though we've removed them from the list, which I'm not sure that we want. So what we need to do is start creating a structure for our node for our pool allocator. And that might look like, I guess we could say struct free node. And that is struct node. No, struct free node. And then struct node. We'll just say node. The naming here is a little bit weird, so we'll just say free. We'll call. We'll just comment this out for now, and I'll rename node to how do I do this? Change to that. Save. True. All right, let's see how that looks. Okay. All right, now, so we can say free node, and this is foo. All right. And then struct pool. Pool foo. I could say this is free foo. And then struct m arena. And struct free foo first. Okay. And then we'll define struct free foo. Foo allocate. And likewise, we need a release. Struct pool foo pool. And then we need to pass in the struct free foo. Okay. And instead of arenas, we're gonna pass in struct pool foo, the pool, and same thing here. Yeah, that's fine. So let us declare a struct pool foo pool arena and I guess we don't need a pointer here for now. And then here we just pass in the pool. No, wait. When I'm building this, yeah, I need to push onto the. Okay, yeah. Something that. What does slist init do? Slist first equals slist and head equals nil. Okay. Yeah, that's fine. I don't need an arena I don't need a pool for that. I just need an arena. Arena. But yeah, that is fine. But when I'm appending, I do need the pool. So here I'm allocating struct foo equals pool allocate. Wait, what is it? Foo allocate, right? Not pool allocate. Whoops. And that takes a struct free foo. What is it? Struct. Oh, okay. Here we go. Yeah, I just need to pass in the pool. Struct pool. Pool. Incompatible struct fee. Okay, so that gives me the struct free foo. Oh, I can't. So I need to. This could be tricky. I don't want to pass by reference. Yeah, that should be fine. I hope it's fine. We'll see if it's fine. So I'm not returning back. Ooh, I'm returning back a free foo. I also need void slist remove, and then I need to pass in the pool and the list and the struct. Actually, maybe I just need. No, I do need to pass in the list and the node struct free foo. Okay. Alrighty. Let's see. We will need to remove the element from the list. Slist free foo. Oops. Right, okay. And then I need to release. So foo release pool free foo. Okay. And then right. right, I need to pass in pool. Passing struct pool foo to parameter incompatible type struct pool foo. Ah, okay. I need to pass in the address. All right. slist remove. All right. I need to, instead of this, I want to pass. I want to do foo slist remove pool foo to. Struct. Why do I need that? Why do I need the struct? Free foo. What is this? All right, I need to pass in the slist. Passing struct pool food. Okay. Let's see. And then, yeah, okay. Okay, cool. And now I just need to implement this stuff. All right. So first, I try to look for free foo. Let's see. Pool. First free foo. If let's see. If result equals nil, else. If it's nil, then I need to result equal m arena push that onto the arena struct free foo pool and return the result. So if it's nil, then we push new memory onto the arena attached to the pool. Otherwise, we will need include memory helper.h. So we're going to say memory 0 results oh yeah, we need the size. Struct or size of struct free foo. Okay. The pool first free foo equals the pool, first free foo, next. Yeah, I think that works. And then for releasing memory, we just say free foo next equals pool first free foo and pool first free foo equals free foo. The next one from this guy equals, so the next one, we push it down. We're pushing the pool down to make room for this first, the free foo. Something like that. Let's see if that works as we expected. Okay, it seems to be working, but we don't know what's happening to the memory. So, let's just say, all right, let's go and look at the addresses. All right. Let's just look at the free foo address. And we'll just do this. For each of those nodes. Okay, let's try that. So we have the addresses. I can't tell 18 in hex. Not sure what that is, but all right. Seems to be working. And we'll just we will go ahead and do this. Print the list again. And then not only print the list, but print those addresses. All right. So the first one we removed was 2. And we can see that that address is being used for 5, which makes sense because the second node we removed was 1. That pushed it to the top of the free list. And so that's what's being used. Now, something I'm curious about is, so this is a reference, but this is memory. Is this being copied by memory? I need to make sure that this memory isn't being reduplicated or whatever. So I need to look here and we'll print out just the foos. Wait, let me look. Okay, so when we're allocating on slist append, we're doing foo allocate. Okay. Yeah, that makes sense. Yeah, I don't think I have to worry about it because this memory here is just like if I put that there. All right, I think it's fine. I mean, I can check. Foo address. Yeah, so it's part of whatever this is. Yeah, 38, 50, 48. Yeah, okay. And then we can do the same thing here. And I'm pretty sure it is being reused. Yes, that data is being reused. All right, so that's a free list, I suppose. Now, something I think I could do is generalize the pool allocator and not just make it about, I could say pool free. Oh, no, I guess I can't generalize it. I was wondering if I could. But it doesn't really make sense. I mean, let me try. For now, all right, so now we have that put committed, not committed, but like, okay. Now we can say we've got that, and we can then declare use size for the entity we want to allocate, and then we just say U8 first free node. And we say, okay, whatever this pool is, and then no, we won't say this. We'll say void. And then we can say pool allocate, pool release. Void pointer. Let's go ahead and all right. This needs to return back void pointer. we get back a void result of the first free node. And we say pool size. Okay, and then otherwise we say first free equals and memory 0 pool size. I guess you can't generalize it because, yeah, I don't know. I'll keep going down this path, but this seems like a fruitless path to me. Because we have to allocate. Yeah, this feels weird. Yeah, free node. First free node. Yeah, I don't think we can generalize it. It's not helping me out. It was an interesting experiment, but I don't think it's gonna work in the long run. But still, this is pretty cool. And maybe I should apply this here now. Apply the lessons here to whatever this is doing. All right, I still have some time. It's only been an hour, right? All right, so all right, so we have an S list here and a node. So let's go ahead and declare also a pool X receive pool X receive free entity first free and this X receive X receive node, and this can be X entity. Okay. I have my build, slist build, slist append, but this needs to take X receive pool, X receive pool, yes, and then I need a remove. struct x s list struct x the free entity What is this? Struct x receive free entity will not be visible outside of the function. Why? X receive free entity. What's wrong with this? X receive free entity. Anyway, right. I need to return back to struct x. X receive S list, X receive free entity. That looks correct. Kind of. Struct pool, struct S list, X receive free entity. Declaration of struct X receive free entity. What is going on? Oh, I must have. Did I? Oh yeah, I accidentally misspelled it. Whoopsie. All right, here we go. All right. Okay. So how did I implement this again? So append. So we get the free X free allocate. Oh, I didn't declare any pool allocator or allocator functions for my pool. Yeah, I should do that. I'll do that right here. So X free entity X allocate. X pool X free feed release. stuff here. All right. So in append, we try to get the first free entity. Free entity. And then we say entity next. At the node. Get an undefined. What am I doing differently? Oh, struct str data. How did that change? That was weird. Okay. And then we need to return entity. And when we're appending slist free entity node. Okay. And similar to this, we just call that slist entity node x node, and then we release that. And then we're allocating. Cool. First free entity. Then, okay. Okay. And then okay. Yeah. Who release is invalid. Right. X C re-entity release. Okay. And then on line 1019. Right, okay. So I need to, this needs to be a pool. use of I guess I could just use the pool's arena. It shouldn't hurt, right? Not necessarily. Yeah, okay. I'm fine with that for now. I mean, not in the final implementation, but for now I don't really care. Yeah, okay. Server. Right. And now we don't want to here, we do want to pass in a pool. And guest list. Don't need to temporary that. Oh, it's X or an atom. All right, and then something I think I need to do is on each node, I need to have a pointer back to the free entity. Yeah. Yeah, I think I need that. Otherwise, I won't know how to get back to it to free it. You know? And then, yeah. Yeah, I think that's what needs to happen. Free and so when I append it, I get back the address of the entity. Then I assign the node data to the data, but I also assign free to that. And then when I remove it, it doesn't really matter at that point. Because when it's being allocated, yeah, that's fine, that's fine. At least, okay. And then here, when we find this reply and it is found, then we can say, this reply x receive node. All right. Okay. So current, whatever this current is, we can say, what is this? Whatever this current is, current, free. That's the entity. So now we can say, x receive free entity release, and then we pass in the pool, and then we pass in current free. Right? Let me think about that. I believe so. Right, I need to, what error is there? Okay. I need to pass in the pool and the S list. Okay. Right, okay. This is fine. Struct X receive S list. S list equal X S list build. S in the arena. Pool and struct X receive pool. How did I declare it here? Oh, right. Okay. Right. Okay. So then we need to pass the address. Okay, cool. That seems to be working. I think it works. I'm actually not quite sure, you know? So let's just go into this line by line. So 577. Break at 577. All right. Step into there. Continue stepping. All right. So opcode. You know what? Let's go full screen. Opcode equals 16. Right. Cool. Continue down here. Okay. Send that. Yep. Send that. Yep. All right. So now we're receiving a list from the X server. So print out list. Okay. Let's step into this. Okay. Print Atom reply. Sequence number, reply length, Atom. Okay, next. Step into there. Step into there. Now we're getting the Atom for WM protocols. Sending it, sending data. Okay, print the S list. Wait, did I release it? I don't believe I did. Okay, yeah, we are releasing. Okay. Print pool. Okay. Yeah, okay, it signed it. The data. Okay, there's the arena. I didn't remove it. I haven't removed it from the I removed it from the free list, but I didn't remove it from the list itself. So like I should have done this. Pool. I need to pass in a pool, the S list, and the entity. There we go. What line do I start at? All right, I want to start at 577. All right, here we go. Let's step into this. Continue down until we, okay, so we receive. Okay. Now we're checking. Everything looks good here. We found it, and now we received it. Pool has some data in it, and the S list has no head. So it's an empty list right now. Awesome. S list, empty. Isn't there an empty? Let me look. I thought there was a function or a macro to see if the list was empty. Yeah, S list empty. Maybe you can't. Maybe they don't look at macros on whatever. Maybe they just don't okay, whatever. Maybe it's not available in the debugger. I don't know. So there is there's memory available to be reused. Um, that's the address of the arena, and the address of the first free entity is similar. Yeah, very similar. So it's in the ballpark. I can believe. Next. And then we want to go down here and also step into the next xintern atom call. So let's print out the pools. So we still have a free entity available, and then our S list is empty. Now we go here, and now we don't have a free entity available. It's been taken up. And if we look at the S list, we see, oh, there's data there in the list. So let's continue down here. We found it. We removed it. Now there's data to be used on the pool. And the S list is empty. Excellent. Right. Cool. Cool. And then this is the atom for WM protocols, and this is the atom for WM delete window. And then one more time, I just want to run that without the debugger. Okay, I think I've accomplished my goal of implementing a pool allocator or a free list, and now I can use that to leverage that to implement X11 events next time. You know, it's been interesting working in C. You know, when I first started this back in, I'm not sure when I started this. July, June? Let me look that up, actually. So it says my first episode on this series was published in June. Maybe June? Let me check. No, June, early June. And back then I only had like a smattering of knowledge of C, and I don't know why I had this image of C that it was this difficult, unwieldy thing to learn and to program with. You know, and it's not been difficult, but it's been difficult and it's been challenging, but it hasn't been impossible to understand what's going on. And it has helped me to understand programming in C has helped me to understand how memory works and is arranged and is organized. And learning these data structures, I've been able to figure out, oh, how do I use memory efficiently and in what way? And I don't know, it's been very, very cool and interesting. Yeah. Anyway, I just thought I would talk about that a little bit. The journey still continues. I'm not. I'm nowhere near an expert in C, but it's been fun. It's been interesting, and I hope to continue with this. And I hope to, once I figure out the X11 protocol, I want to move on to other things to help me create applications in this programming language. And all of this is in service of developing my own technical expertise, my own technical skills, my own technical stack and code base that I can use to create anything I want. Um, all right. I think I'm going to end it here. It's really difficult for me to end these. I don't really know what to say. I don't really know how to say bye because in some ways, I'm not really speaking to anybody, but in other ways, whoever's watching this, whenever they watch this, if they watch it, I'm also speaking to them. Anyway, uh, waxing poetic is kind of weird for me, so I'll just say goodbye. Goodbye. And goodbye. Goodbye. Bye. All right, bye.